Changing the base of a logarithm. It is really important to be able to change the base of a logarithm, because when we look at the second example on this video, we're going to have two logs given to us with two different base values, and it is vital that when you're solving problems involving logarithms that you have the same base to the logs. To do this, we're going to look at two extra laws. We're going to look at the first one, which is log to the base a of x is equal to log to the base b of x divided by log to the base b of a. The b can be any base value that you want to use, so it could be 10, 7, anything you want, but it will give them a standard base value. And the second rule, which is probably the more useful rule, and we're going to use the second rule on the second example, is log to the base a of b is equal to 1 divided by log to the base b of a. So we're going to use these two rules to solve two questions. So the first one is to find to three significant figures the value of log to the base 6 of 15. So you could just easily type this into the calculator as log to the base 6 of 15 and it will give you a value, but we want to see what effect we want to practice using this top rule with this problem. So log to the base 6 of 15. So we're going to use this top rule. So firstly, in our part question here, what is our x? Well, our x is our 15 and our base value for the log a is 6. That's going to be helpful when we're looking at using the rule. So log to the base. Now, as I said, you can use any value you want, so I'm going to use the value 10. It's quite a standard value to pick is 10, so if you're looking at converting into a similar base, go for log to the base 10. So the x is 15, so I'm going to put that in from the rule, divided by log to the base 10 of 6. And if you pick up your calculator and type it in, you get the answer 1.51 to three significant figures. As I said, it doesn't matter what value you use for the base, but 10 is a standard one to use. If you want to use 8, you'll get exactly the same answer. If you want to, pause the video at this point and have a go with a different base value to convince yourself. Right, the second question we're going to look at is solve the equation log to the base 4 of x plus 5 log to the base x of 4 equals 6. Now for this, you'll notice that we've got two different base values. We've got the base here of 4 and the base here of 6, and we can't solve this in its current form. What we're going to use is we're going to use the second of the two laws I showed you at the start. So log to the base a of b is equal to 1 over log to the base b of a. Now this rule is vital that you learn. It's not given to you in your formula book, and it's one that you'll probably inevitably have to use in your exam question. So remember that log to the base a of b is equal to 1 over log to the base b of a. So now we look at our question, which is log to the base 4 of x plus 5 log to the base x of 4 is equal to 6. As I said, we've got two different bases here. Now, the easiest one to change in this question is going to be this one. So we're going to make it log to the base 4 of x. So if we apply the rule here to this second part in the question, we're going to have 5 over, so that will be log to the base 4 of x equal to 6, and obviously we've still got the other log to the base 4 of x. Now in this current form, this looks like quite a difficult question to answer, but at this stage, just to simplify it for us, we're going to set y equal to log to the base 4 of x, and then once we've found our solutions, we'll then for y, we'll then re-put in log to the base 4 of x. So I'm just going to rewrite our question to y plus 5 over y equals 6. And what we want to do is we want to multiply through by y to eliminate the y on the bottom of 5 over y. So y times y is y squared plus 5 is equal to 6y. We rearrange this because we've got a quadratic, and remember when we're solving quadratics we need to have our equation equal to 0. We're going to have y squared minus 6y plus 5 equals 0. And this should factorise quite nice, and it does. It factorises to y minus 5 and y minus 1 equals 0. Hence, we've got two solutions here. We've got y equals 5 and y equals 1. So now if we look back and substitute in what we said y was equal to, we're going to have the two following things. So we're going to have, therefore, log to the base 4 of x equals 5, and we've also got log to the base 4 of x equals 1. Now, remember what the definition of a log is. So 4 to the power of 5 will give us x, and likewise 4 to the power 4 to the power of 1 will give us x. So 4 to the power of 5 equals x, and on this side 4 to the power of 1 equals x. So x is equal to either 4 or x is equal to 1024. So these are our two solutions to this question, but the first thing that we had to do in this second example was to convert our problem so we had the same base value. Now, as I said, you must learn those two rules as well as the other laws that we've covered in the videos.